So 15.2, looking at recursive and explicit formulas, the rules for a geometric sequence. So in this particular case right here, that is an explicit rule. It is explicit because I'm looking for f of n, some term number. If I'm looking for the 7th term, all I do is put 7 in for n here, and I get the answer. This is why I told you earlier, an arithmetic sequence is linear. So if it's arithmetic, I'm going to abbreviate here, it's y equals mx plus b. Whereas a geometric sequence is an exponential function. In other words, our variable is an exponent here. Now the reason geometrics are exponentials is because they have greater growth or greater decrease in value because you're either multiplying by a value that's bigger than 1 or multiplying by a value that's less than 1. Whereas a arithmetic is linear, so you're always adding or subtracting. So it doesn't grow as fast or decrease as fast as quickly. Okay? So on this particular problem, it says the given rule is an explicit. This is an explicit rule because I can plug any value in for n and get the exact value I want. Because I don't need to know the value of the previous term. This is not recursive. If it's recursive, I have to know what the previous term value was. In this case, I don't. I just have a formula that I have to plug in. So the only unknown in this expression is n, which is the term number. So n represents the term number. So again, if I'm looking for the 7th term, I just put 7 in for n. Again, this sequence is called a geometric because we're not adding or subtracting the same amount. But in this case, if we look at the formula itself, we're multiplying by the same amount. Our common ratio here is 3/2. Because it's bigger than 1, that means what about this sequence? It's going to grow. It's going to get bigger, increase, go up, however you want to say it. So it says the sequence is a geometric sequence because each term is the product, very good, of the previous term. We're multiplying, we're not adding or subtracting. Very good. So again, I'm going to skip a lot of this. I'm going to just do problems for you because the book has done a lot of examples. So if you go to the next page, this explain 1, okay, they work a lot of this out. They go through, again, a lot of stuff here is going to be a little bit different than what I would do, but hopefully as I go through a problem and work it out and guide you through it, it'll help. So this is the fill in the blank one. Again, I'm going to go ahead and skip this. If you want to go back and look at it and try to fill it in yourself, you can do so. What I want to do is immediately to the your turn. And I'm going to do this with you. So I'm going to write this one out and work this one out. So in this case, they give us our values in a table. I know immediately what my common ratio is. What is my R? 2. I can look at the table and tell that. I'm multiplying by 2 every time. Now again, if you can't see that, how do you come up with the common ratio? You divide. You divide a term by its previous term value. Okay, so that's another way to get it. You have to know the common ratio. Here's how you write the recursive rule. This is as easy as it gets right here. If I'm looking for f of n, recursive is always based on the previous term value. So it's f of n minus 1. That's how you denote the previous term. It's the term before this one. And how do I get this value of the term? I take the previous term value and multiply by the common ratio, which in this case is 2. There's the recursive rule for that particular problem. That's easy.
Is that all we're doing?
That's what you did there. Now, The directions say, and an explicit rule. This is a little more difficult. So how do you get the explicit rule? The explicit rule is just like we said with a linear. You always have a starting point. Our starting point here is not our zero term like with a linear function. Instead, it's our first term. Our first term here is 7. So, again, to kind of explain this, if I want to get term 2, what do? I take the first term and multiply it by 2, the common ratio. If I want to get term 3, I can take term 2 and multiply it by 2 and get it. But to write an explicit rule, you have to have a starting point. So let's start with 1. I'm going to take that value and multiply it by the common ratio once to get the second term, but twice to get the third term. Because what's 7 times 2? 14. But then 14 times 2 is? Okay, if I want the fourth term, I take the first term and multiply it times 2 how many times? 1, 2, 3. If I want the fifth term, I take the first term and multiply it times the common ratio. 4. 1, 2, 3, 4. So to get the term, I have to multiply it times the ratio 1 less time than the term number. Let me say that again. If I wanted the fifth term, how many times did I multiply it times the common ratio? 4. 1 less than the term number. So the explicit rule is this. F of n equals. The basic rule, I'm going to just write out the formula, is A1, where A1 is the first term, times R, where R is the common ratio, raised to the n minus 1 power, because again, the exponent is going to be 1 less than the term number. So for this particular problem, our formula would be, what is our first term? 7. What is our common ratio? 2 to the n minus 1. There's your formula. So in a linear sequence, we start with the zero term. In a geometric sequence, we start with first term. In a linear sequence, we use the slope, what we add or subtract. In a geometric sequence, we use the common ratio, what we are multiplying by. So you tell me here, recursive rule for this one. What's the first thing I have to figure out? The ratio. Okay, now I look at this one. This might be a little bit more difficult, but maybe you can look at that and see. What am I dividing by each time? I'm dividing by 4. Well, we don't do division, we do it as multiply. So the common ratio is 1/4. Okay, you divide, you multiply by the reciprocal. So the recursive rule, f of n, is the previous term times your ratio. That's the recursive rule. It's always that. Never changes. So what's the only thing you have to find to get the recursive rule? The ratio. The explicit rule is f of n equals, what do I have to have first? First term. What is our first term here? 128. Times what? 1/4, our common ratio, raised to the n minus 1 power. There you go. Did not ask us to solve it here. All it asked us to do was what? Write the formulas. Now, are we going to have to solve? Absolutely. But it's easy. Super easy. So again, I'm skipping the examples they've done in the book, and I'm going straight to the your turn problem, and I'm going to work these out with you, or work this one out with you. So it says, use each geometric sequence to help write a recursive rule and an explicit rule for any geometric sequence. Okay? So what does that mean? What's different about this and the others? Use each geometric sequence to help write a recursive rule and an explicit rule for any geometric sequence. Is it any different than what we were just doing? No, it's the same thing. Okay, it's the same thing. So, recursive rule. F of n equals what? F of n minus 1, because it's always based on the previous term, times r, which in this case is 2. Good. So at this point, we should be able to find the common ratio pretty easily, yes?
Yeah.
Okay. So our explicit formula is f of n equals 6, our term 1, times 2, our common ratio, raised to the n minus 1 power. Good. So again, they give you another example here, completely worked out, okay, constructing a geometric sequence given two terms. Now, the thing is, these two terms may not be consecutive. That's what makes this a little bit more difficult, okay? So again, they've got an example worked out. I may not work it out the same way. No. Here's the fill in the blank one. If you want to go through the steps and kind of look at it as a guide for the previous one, you can do that. But here's where I'm going to start. Your turn, and I'm going to do this one with you. Okay, so the third term of the geometric sequence is 1/27th. So what I'm going to do is I'm going to write a of 3 is 1 over 27. So I'm just using some notation here. The fifth term is 1 over 243. Okay, so I can't get the common ratio immediately. The reason I cannot get the common ratio immediately is because they're not consecutive terms. I can't look at it and say, this is what I did to get the next one. However, I can look at it and determine that my common ratio is a value that's what? It's positive, and something that is also, it's division, so it's a value that's less than 1. Now, how do you know it's division? Because what's growing here? The denominator is what's getting bigger. So that means I'm multiplying by a fraction that's less than 1. Everybody get that? Okay. So how do I figure out what the common ratio is? How do I figure out what term 1 is? How do I do all that kind of stuff to find the value? Okay, so here's what we do. We came up with a generic formula for geometric sequence, and this is what we had. F of n equals a1 times r to the n minus 1. Now, if that's our generic formula, our explicit rule that works for any geometric sequence, looking at this particular problem, I can start to find values. And the way I do that is by plugging in things I know. So what do I know here? I know term 3. F of 3 is equal to what?
3 times r to the n minus 1.
Well, f of 3 is 1/27th. Do I know what the first term is for the sequence? I do not know what a1 is. Do I know what r is? No, I do not know what r is. Oops. Do I know what n is?
Yes, it's 3.
N is 3. So what would 3 minus 1 be?
2.
2. Did everybody kind of follow that or not? All I've done is plugged in the values directly in here. Now, can I do the same thing for f of 5?
Yeah.
Sure. 1 over 243, so that's a1, times r to the fourth power. Are we still okay? Okay, now, how are we going to use that to determine the values of a of 1 or r, one or the other, or both? Well, let's rewrite our values here. Instead of 1 over 27, let's write it as an exponential, an exponent. What is 27? 3 to the what power?
1/3.
Okay, it's 3 to the third. 27 is 3 to the third. So that's 1 over 3 to the third. So really it's 3 to the negative third power. Now, let me write it over here to the side so you can see that. So 1 over 27 is 1 over 3 to the third. If I want to make an exponent that's negative, positive, we said write the. So if I want to make a positive a negative, I write the reciprocal. It's the same concept. We still okay? All right, now, let's do the same thing for 1 over 243. What is 243? 3 to the what power? 3 to the fifth power, right? If you're not sure, do it on your calculator. So really, this is 3 to the negative fifth power. Okay? Okay, so as we look at this, we know it's decreasing. We're multiplying by something that is less than 1. Nick said it's 1/3. So let's see how we get 1/3 in that. So we have here, we have right here a of 3 and a of 5. So if I want to get a of 5, that means I take a of 3 and multiply times the common ratio once, and that gives me a 4. And then I'll multiply it times the ratio again, and that gives me a 5. Everybody follow that? So now we plug in the values. What is a of 5? A of 5 was 1 over 243. A of 3 is 1 over 27. And that's times r squared. So now at this point we can find r squared. How do I get rid of the 1/27th? Multiply by 27. Multiply both sides by 27. Okay? Everybody good? What's 27 times 1 over 243? Do that real quick on your calculator. Do math frac. I know what you should get. 1/9. So I have 1/9 now equals r squared. So I've gone from here to right here. So now how do I get rid of the squared? I take the square root. What's the square root of 1/9? 1/3. So 1/3 is, that is my r. That is my common ratio. That is still not my formula. Because what is it I still don't know?
The first term.
I don't know the first term, A1. Okay, but can I find A1 now?
Yes.
Sure. Because now I know what R is, I can take R and plug it in either here or here, either one, and figure out what R is. Now, what's probably the easiest one to plug it into? Probably the top one, okay? Probably the top one. So, let's take the top one. We know 1/27th equals A1 times, now 1/3, that's our R, squared. What is 1/3 squared again? 1/9. How do I get rid of 1/9? Multiply both sides by 9. Multiply by 9, those cancel. So now I'm going to figure out what A1 is. 9 times 1/27, math frac, I get 1/3. So in this case, what ended up happening? Our common ratio was 1/3, but also our first term was 1/3. Questions?